Hello all, and welcome to this video tutorial on Check Point firewalls. This is the first of hopefully many videos just covering off different configurations on the Check Point firewalls. In these videos I'm going to be using the same setup. It's all on my laptop and I'm running everything in a virtual environment using VMware Workstation 9. For the purposes of demoing I'm using Check Point R71. Reason for using this, it's just one I know quite well. It's very quick, so it's nice and easy to show demonstrations when I'm pushing firewall policies, and I'm going to be doing them quite quickly one after the other. So some of the later versions of Check Point tend to be a little bit slower. So as I say, it's a nice, simple, and easy configuration guide. I haven't done a video on the configuration and actual installation of the checkpoints. If anyone wants this, please leave a comment. But I basically started with a fresh template, so I've got, just to show you the setup I have, 4 machines set up at the moment. I've got a Stingray load balancer, which comes from Riverbed. This will be used later on. Checkpoint SMS, which is the security management server. Checkpoint SG, which is the security gateway. And I've got server 1, which is a Debian squeeze Linux box. The server is going to be used for a few different things. It's going to act as a web server. It's going to act as my test box to check internet connectivity, things like that. So it's going to host a number of different services, but for the purpose of this video it's very simple. I'm just going to get outbound internet connectivity, and I'm going to show quickly inbound connectivity as well, so try and pull up a web page from the external interface on the checkpoint. Okay, so let's go to our smart dashboard. So very simply, security gateway, I call it SG. Doesn't really matter what you call them, these are just your identifiers, but this is the management server. So all it's doing is running the NPM and logging in status blades. Very simple topology, but one interface, and this IP address 192.168.94.5. This is my host only network within VMware. So I'm using 2 different networks: host only, which is going to be for all the different virtual devices to chat to each other, and the NATed network, which is basically a network which talks directly to my laptop's interface, so I can map myself out to the internet through my laptop's IP. So it's a nice and easy setup. Security gateway, this has got 2 interfaces. It's got the management one, which is on the host only network, and it's got the external NATed interface. So for my topology I've got external, this leads out to the internet. I've enabled anti-spoofing on this, so very simple external anti-spoofing, so it's looking for any external IP addresses. So those are your RFC 1918s, your 192.168s, your 10.0.0.0, and the 172.31.16 through 31, etc. So here we've got it set to prevent, so if it sees anything on that it shouldn't, it'll block it. And on Ethernet 0, internal network defined by the interface IP and net mask. Therefore, on this interface, it is only expecting to see addresses in the 192.168.94.0/24 network. If you need to widen that, you can be specific, you can define a group. However, we're not going to have that. You use this specific potentially if you've got, this is a handoff interface into another layer 3 environment where you've got multiple different VLANs with different IP addresses. You'd need to define them here. A lot of people tend to be lazy and just turn anti-spoofing off. This is a really good feature, and it's there to protect the environment, so absolutely worth using. So we'll leave as is, so that's fine. Let's go out. So all I've got is one rule here. Typically when you've rebuilt a management server, you're left with no rules. So I've added one in just because I've done a few tests on it, and you have to leave at least one rule on. So for the purpose of this demonstration, technically this should be blank, but as I said, we've had to add one. NAT, we can use automatic NAT for this. Differences between manual and automatic NAT. Automatic NAT is very much focused on sort of small business. You don't know many environments where you can get away with using automatic NAT right the way through the service and the lifetime of the checkpoint. You tend to always have to go back to manual NAT at some point. Good example is automatic NAT. You can do hide and static. So for instance, we're going to be using hide and static in this example, but when you want to do things like PAT, so the port address translation, you can't really do that on automatic NAT. So you can mix and match them, so you can have some automatic, some manual. However, you're pretty limited to where the rules go. So typically you can only add, there we go, so you can only add rules at the bottom or the top. So here it's basically saying these rules are computed automatically by the system. So the only way to get rid of them is to basically configure the settings here. So it has its limitations automatically now, and I would sort of recommend if you're going to go with one or t'other, you kind of make that choice at the beginning, because if you have to do it later, it can mean, you know, having to unconfigure a few different things, and it's not particularly pretty. But for this example, it's absolutely fine. So what I'm going to do now is I'm going to jump on the Linux host I've got. What I want to do is just confirm there is no internet connectivity. This box has got an IP address 192.168.94.50, so it's on that host-only network. Default gateway is 254, which is the security gateway. So what I'm going to check is have I got internet connectivity now. Fired up tracker, so already you can actually see it's trying to do some DNS lookups. So what we'll do is we'll just confirm that we can indeed not access the internet. So I'm going to use curl here, which is just basically try and pull up a page. So if I do www.google.co.uk, probably not going to see a hit on the tracker because it's not going to get past the DNS stage. So if I hit that, I'll probably just see an entry on tracker for this again. So it's going to try and do a DNS lookup. It's going to fail. There we go, as expected. So we're going to cancel that just to prove the HTTP is not working. I'll just do a manual curl -I on 8.8.8.8. So it's going to try HTTP on that IP address. So we should see an entry shortly. There we go. So that proves the point that web access isn't working. So really good actually that we've seen both of these, because in order to get internet access, we're going to need to have DNS lookups and HTTP access. So here you can see our DNS server is 8.8.8.8, which is Google's public DNS. We don't have an internal DNS server here. So for what we're going to have to do, this helps us because we can start to build our rule set now. So I'm going to add a rule above here and call it internet access. Now I'm going to basically create a network for this rather than doing it on a node basis. So I'm going to call this test network 192.168.94.0. Comment, this is my test network. Doesn't really matter, you don't need to include that. Broadcast address I'm going to include. Now, really importantly, it's fine adding a rule that says allow HTTP and DNS, you know, UDP 53. That isn't going to work on its own because it's not going to be a NAT rule. So we need to add NAT. Now, this goes back to the comments I made earlier about automatic address translation. We're going to use automatic address translation. We're going to hide this network behind the gateway's external interface IP address. So we're going to leave that setting as is. If we wanted to hide it behind a different IP address, which is hosted on that the security gateway, we can do so here, or we can do a static one-to-one translation and put the IP address in here. As I say, let's keep it simple. Hide it behind the gateway. That looks fine. That looks fine. Let's click OK. So if we quickly go back into here, that's our NAT rule there. So anything from test network to test network is kept the same. Anything from test network to any destination, the address is hidden. So that's the rule we'll expect to see used when we try and access the internet. So line 4, let's keep an eye on that. Okay, so internet access source, we use test network. Destination, it's going to be any. VPN, don't need to worry about that. Service, let's add our services. So HTTP and DNS. So DNS domain name. Let's accept that. Let's track it. So tracking it basically means when we put log, it's going to put an entry in Smart View Tracker. I'm going to just put in allow access. Comments aren't required, but they're actually quite handy. They're great, you know, if you're keeping an eye on rules and just thinking, you know, that's what that's for. Name, some people look at, well, you know, the name gives you that, but comments fantastic if you're going to put things like your change number. Depends on the environment you work in. You might want to keep track of everything, so changes to make sure things all, you know, been authorized, etc. So, but as I say, it's not a requirement. So let's check that. We've got internet connectivity, HTTP and DNS, accept, access test network, and we've nothing. That looks great. So we're going to verify the policy. Let's save it. Let's take off quas because we're not using quas. let's verify that policy. So I'm just going to check the rules, check the order, everything looks fine. Let's push that policy. Okay, that's fine. Let's just mention about implicit rules. Doesn't matter. Let's click OK. Network. Now we're going to install this on the single firewall that we have. I'm going to create a database revision as well. So we're just going to create, keep the name and the comment the same. This basically creates an entry in a change database so that if we need to roll back, we can quickly do that without having to undo rules. Now, this is a simple rule, so we could easily just delete that. When it gets a bit more complicated, this feature is absolutely excellent. So we'll create that, click OK. It's going to create the new version, store it in the revision database, ready for future rollbacks if required. Version was created. Let's click OK and let the install process take place. So all it's doing is verifying that policy. If there was a problem with it, it would actually stop the installation. It's going through absolutely fine. It's installing and it should be done any second. There we go, brilliant. So let's close that. So let's open up Tracker. Right, we've got it on automatic scroll down, so it's going to keep updating. So let's try our curl command one more time. Let's try Google. Brilliant. We've actually got a hit there. So we've had a 200 response from Google. The DNS entry, look, the DNS has gone through fine, so we can see our first rule there. Main UDP, that's gone through absolutely fine. And let's look at this one. So that's again source, that's our server, destination, Google, port, fantastic. Now, interestingly, if we go into this bit underneath more, we can see the map rule that actually translated that connection. So as we can see, it was map rule number 4, which was the one I said to pay attention to earlier. So this is great if you need to troubleshoot that, because you'll get instances where show you one of the problems with automatic NAT is, let's say for instance we have a few different interfaces on our gateway, our security gateway. What we could have is potentially an address from test network to say our DMZ interface, which is on the same firewall, will actually be NATed, because that's basically saying any destination. What we'd have to do is add a rule above it, because it reads it in order, that says from test network to DMZ network, keep it original. So this is where automatic NAT can actually be a bit of a pain. What you'd have to do is add a rule in at the top that says from test network to, you know, your, let's just use one of these, for example, DMZ zone, keep original, and that would work. But you know, you're getting into the realms of what was the point in using automatic. You start to mix and match. You can do that happily, but I wouldn't recommend it. So that's worked fine for internet connectivity, as we can see. So what I'm going to do now is make an internal connection. So obviously, as I said, we've got an external interface. Obviously, it's on a private IP address, but that's just because of the setup I have. So I'm going to create an external to internal connection on the IP address ends in 133. So I'm going to host the 133 address on this checkpoint. Now what it's going to do is it's going to automatically add that into the ARP configuration. So it's going to proxy ARP. It's going to basically, when my laptop calls for that IP address, it's going to shout, I have the IP address, and it's going to shout that out. So what I'm going to do is create a node called, let's create one called www.test.com, and let's give it an address 192.168.35.133. Okay, now the only reason I'm doing that is just to keep a track of the logs. So I'm also going to create a host server on 192.168.24.50. So I might as well configure this. This is like the IPS protection. So it's a web server. I'm going to go into that. It's Linux, and we're going to use general. We're not running any of the others. General, port 80, brilliant. That's just to keep all the IPS protections. You can actually, if you go into it, the interesting protections, those are all the protections it offers. You can go into those. You can set, you know, the level you want, so high, etc. We're just going to keep it standard. So okay on that. Now, what we need to do is create a static NAT entry. So we're going to go into NAT, add static, and we're going to add the address in here that we use for www.test.com, which was 168.35.133. So it's going to translate this server to this IP, and vice versa. 192.168.35.133 will translate directly to server 1. So we're going to add that in. And what we're going to do is we're going to add a rule. We'll have it above. we'll put inbound access, and what we'll do is put source any destination. We'll put our server there, service, it's going to be running HTTP, and we're going to track that log, and we're going to allow that inbound HTTP access. Yeah. Excuse me. So that's great. We've created our static NAT. We've created a rule. That's okay. So let's verify that policy. It's always good practice to verify beforehand. It means you don't push the policy before you've seen it's actually failed. So it's about fine. So let's push that. Again, we'll create another database revision. Now what we could do is we could say added rule for inbound access as an identifier. Okay. Create the version. So what I'm hoping is we'll be able to fire the browser. Let's do that now. And let's firstly check our web server. So all we're going to do is check that we've got a web page. So if I go to index, so that's our web page, www.test.com. This is a default web page, so it's just a standard Apache 2 installation. Not done anything fancy with it. Check that. Again. So let's go to here. Now we use that address. We've used formatting 68.35.123. There we go. So that's gone through from www.test.com, and there's our hit on the firewall. So that's my host machine. Let's just confirm that. There we are. 35.1. Fantastic. So that's worked absolutely brilliantly. Now, so what we're going to do, so here we've got some interesting stuff. We've got some other devices trying to do some name lookups, so that's off for its network. It's not part of the demo, so we don't need to worry about that. The important thing is it was being blocked. Now, what we can do is a further bit of security. What you'll typically do is add a rule at the top of your firewall, which I think a lot of people will refer to as your stealth rule. What that basically does is stops direct communication to your firewalls. So what that does is it means your firewall won't drop any scans, things like that. So we'll add that in. That's just a little extra layer of protection. We'll create a revision database every time. Fairly happy this isn't going to go wrong. So that's basically your, it's stealth. It drops the packet. It doesn't respond. If you put reject, which is one of the options underneath action, which I'll show you, the host that's trying the attack would actually see that. So we're just going to drop that packet. So here's your options: reject. A few other options for later on, but we've stopped the drop. What you can also do on here is add section titles. So you can put section 6 firewall management like that. You can put inbound rules. You put, it's just again, not required, but great for keeping a track. It's just good housekeeping. And clean up. There we go. And it's just a nice simple way to keep track of your rules, so you can expand and keep these out of the way if you need to, so you can just focus on certain rules. But yeah, so it's a fairly basic feature. So we've basically set up some internet access for one of our nodes. We set up inbound. I think that covers off the first part of our demonstration. So in the second bit, what I'm going to do is I'm going to cover things like creating some more interesting rules. So I'll add another interface. We'll create a DMZ environment. We've also got as well a Stingray load balancer to have a play with. So what we'll do is we'll host that on the checkpoint. So the Stingray sat behind the checkpoint firewall. So here's an interesting one. Stingray can't contact its gateway. That's because the checkpoint's denying ping. So what we could do, just quickly, is add a rule in that basically allows the checkpoint on .30 to talk to it. So it'll have to be above the stealth rule, because if we put it below, this rule base is read in order. So we're going to add in here Stingray. Now you can do this within the global policy. You could actually put allow ICMP before first rule, but I don't like to use that. I like to make sure I know everything about the traffic and what I'm doing with it. So let's create a host entry here. So let's go to Stingray. 94.30. Now it's a web service. Something like that. Architecture. Let's keep that like that. So we've got Stingray. So I'm going to add that into my source, destination, gateway, and service ICP, echo reply, and ICP echo request. Allow that. We're going to track that. Allow Stingray LB to test gateway connectivity. Brilliant. Push that again. Just going to go through that. So that should bring up our Stingray. And what we should see, yeah, so here we go, look, stealth rule. We can actually see where the Stingray was trying to hit it. So go into that, ICMP was being blocked. So hopefully what we'll see is once the pulse is pushed, that actually comes back up. There we go, perfect, that's all green now. So, as I say, in the next video, we'll put the Stingray into action. We'll put that in DMZ, and we'll have that talking through to a web server. And we'll do a few more interesting things, but hopefully this has been informational and hopefully helpful. And if there's any comments or questions, please have them. Thanks very much for watching.